Hi everyone, so now we will talk about pseudocode and flowcharting. So first up is, what is a pseudocode? A pseudocode is an informal program description that does not contain code syntax or underlying technology considerations. It summarizes the program flow but excludes underlying program details. So it just means po na, for example, there is a program, or you're going to create a program, rather you're going to think of the algorithm. Now what is algorithm? Now algorithm is the whole process on how you're going to do the program. Okay, so what does that mean? Example, this is a pseudocode on finding the area and perimeter of a rectangle. So in pseudocode, you're going to think of the algorithm. Now how do you find the perimeter of a rectangle? So first step is, you're going to think of how you're going to do it, no? So that's what algorithm is. In creating a pseudocode, you always begin, or you always start with begin and ends with end. And then inside those, we are going to put the process, no? So the process are input length. We also have perimeter equals. So this is the process. Sa kanisya, the perimeter equals 2 times length plus width times area. Okay? And then um, this one is input length or width. So you're going to ask the user to input length and width. Then process area equals length times width, sorry. Then print the perimeter and then print the area. So ito po siya, dapat area nandito sa next line. It's a clerical error or typo error of the author. So, and then example number 2, it's a pseudocode to calculate the sum and average of 10 numbers. So ito po siya, you will ask, or you will are going to calculate yung sum of the average of 10 numbers. So again, you are going to think of the algorithm on how you're going to do the program, and then you are going to put that inside your pseudocode step by step. As you can see, that is in a step-by-step process. Now, how do we do that in a flowchart? So a flowchart is a program that depicts the flow of a program. The figure shown here is a flowchart for the pay calculating program shown in this figure. This is program 1-1. So again, see pseudocode, it's begin and end. See flowchart, it's start and end, as you can see there. So there are symbols in flowchart. We will start with the terminals. So si start and si end po, it's an oblong shape. It's a terminal. It's represented by rounded rectangles or just simply oblong. It indicates a starting or ending point. Now, the next one is the input and output operation. As you can see, input and output operations are represented by parallelograms. So parallelograms, so display, that's output, right? So sa atuang example in our C++ basic, we displayed hello world, so that is an output operation. So that means that it will be in a parallelogram na shape. Do not forget that arrows should be connected to the next operation. So pag wala siya nakakonect, automatic minus points tayo, no? Because arrow lines here, or the flow lines, these are what you call flow lines, are the ones representing the flow of your flow chart. Okay? So read ours means it's asking you to input. Then we also have the processes. So processes are represented by rectangles. It indicates a process such as mga calculations. So in programming, most processes are calculations, no? In our daily lives, processes are, for example, eat, no? That is a process, right? Go to school. That's also a process. Okay? So those are represented by rectangles. Now we have 4 flowchart structures. We have sequence, we have decision, we have repetition, and we also have what we call case. A sequence structure just simply means a series of actions that are performed in sequence. So, sequential siya pag pasunod, no? Sunod-sunod po yung process. Decision structure is pag may decision yung program mo. Let's say, for example, this one. Is x greater than y? So, you are asking. So, you're asking if it's x is greater than y. So, that's a decision. So, if yes, if no. So, in writing or creating a decision structure, you should always have y or yes or n or no. Okay? So, this also is an example of a decision structure. Repetition structure. So, example po niyan is this one. Here, we have the C++ code, no? So, while x is less than or less than y, so mag-increment si x, meaning magtaas si x ng value of 1. For example, the value of x here is 4. The value of y here is 6. So 4 is less than 6. That is true, right? So if it's yes, then add 1 value to x. So babalik siya dito. And then the value of now of your x is 1 plus 4. So magiging 5. So is 5 less than x? Still no. Still yes rather. It's still true. So babalik ka sa flow. And then 5 plus 1 magiging 6. Is 6 less than 6? It's still yes, right? Actually it's false na, no? 6 is less than 6. So that's the time that it become false. So bababa siya dito na flow. Okay? So that is repetition. Pabalik-balik yung flow ng uh, code mo. So for the next one, we have to control the repetition structure. Actually, there is the action performed by repetition structure must eventually cause the loop to terminate. So otherwise, an infinite loop is created. Okay, so in this flowchart, segment X is never changed. Once the loop starts, it will never end. So how can this flowchart be modified so it is no longer an infinite loop? Answer. So by adding an action within the repetition that changes the value of x. So dito, wala pong value, wala pong change yung value ng x. So paulit-ulit lang yung loop, it will never end. So if you are going to put 1 or change the value of x, then that's the time na mag-terminate yung flow ng yung code mo, no? So we also have the case structure. Case structure is just like yung yes and no na structure, repetition structure, but it's more than 2, no? So we have 3 cases, 4 cases. So hindi lang po yes and no yung sagot. We have these 4 cases here. If years underscore employed is equal to 1. So case 1, pag ganito daw po, 1 year ka na employed, yung bonus mo is 200. Pag 2 years, bonus mo is 200. Pag 3 years, bonus is 400. Pag more than 3 years, yung bonus mo is 800. Okay? So, other case structure, for example, the operations in mathematics, we have plus, minus, times, and divide. So, case 1 is plus, case 2 is divide, case 3 is times, case 4 is minus. Okay, so those are examples. Now, we also have connectors as part of our flowchart symbol. So, connectors. A here is a connector. Now, there are instances po kasi na when we make flowcharts, sumobra na po siya. So, for example, this is the first page, ito. And then, wala nang space below this square here. So, you make a connector and link it to the next part of your flowchart. We also have modules. Now, the position of the module symbol indicates the point the module is executed. Now, a separate flowchart can be constructed for the module. We also have combining structures. No, that's a very common here in EDP 101L. So you are going to combine the structures. So you combine the sequential with the decision and etc. So review, what do each of the following symbols represent? So number 1 is terminal. Next is input-output operation. The rectangle is process. The Diamonds is what we call the decision, the circle is connector, and the oblong is, sorry, this one, the last one is the module. So it's a rectangle with a rectangle inside. Also, let's name the four flowchart structures. Okay, answer. Those are the sequence, decision, repetition, and case. What type of structure is this? This is a repetition. What type of structure is this? This is sequential or sequence. What type of structure is this? This is four cases, right? So that is case structure. How about this one? This is a decision structure. So review. These are the symbols with their names and with their functions. So you can read that into your sim or your modules. Okay, this is an example of a flowchart from a program. So this must be just the addition of two numbers lang. Okay? So declare variables num1, num2, and sum. So start and stop. This should be end, okay? This should not be stop. So this should be end. Please change. So kanisha, this should be initialization. So actually, minsan, we use hexagon for this part, but we can use rectangle, no? For the declaration of variables. And then read is output or input operation. So read should be in a parallelogram. Process is sum equals a plus b. Then parallelogram is output, display sum, and then end. Now this is a flowchart of one of my students' daily routine, which was submitted. So start and end. Start when his alarm rings. Okay, so now your decision in life na, should he wake up? So if yes, he will be eating breakfast, then take a bath, then join classes, start making activities and assignments, then eat lunch, and after that eat dinner. Then end. If he will not wake up, then go back to sleep. So is he going back to sleep? It's also a decision. So if yes, tulog siya balik. So end. If not, then he will also play Valorant or some video games. Okay. So for your activity, you are going to make your own flowchart on your daily activities in life. That would be submitted. I will be posting that on Blackboard. So thank you so much for listening to this video. Hope you learned something. Have a great day.